Hello students, good morning to all. Welcome to your beautiful channel Firjan. Today we discuss electrostatic potential and capacitance lesson, second lesson in 12th standard. In this one we discuss what is a capacitor, what is the its property called capacitance. So means that capacitor has some property that is capacitance. That capacitance we discuss. So, what are spherical capacitor? How to store energy in chemical capacitor, spherical capacitor, that we discuss. Before that, see my videos. It is very useful to who and all preparing for JEE and NEET. It is useful. Please see the videos, subscribe the channel and share to your friends and relatives. See, now we start capacitors. So myself ready. So it's your beautiful channel Firjan. See, we discussed today capacitors. Before that, some electrical devices require very high current, means very large current they require. So what now, 25 to 50 amperes of current. Why now? While starting like motor, fan, camera flash, these and all require more current to start the device. So why it will require more current? Now it has more static friction. So it requires sudden supply of energy. So that can be provided by a device. That device call it as capacitor. The device call it as capacitor. So about the capacitor we discussed today. What now, see here, I write some basic. See, some devices. See here, some devices require very high current. So means 25 to 50 amperes of current required to start them. Like motor, fan, camera flash. These and all require more current. Why it will require more current now? It has more static friction. So to overcome that static friction, it requires suddenly more amount of energy. So that more amount of energy can be supplied by a device, call it as capacitor. It is the device, capacitor. It is the device which stores electrical energy. See here, capacitor is the device. It is the device which stores electrical energy. Electrical energy. See here, capacitor is the device which stores electrical energy and supply it at once. Supply it at once means suddenly it supplies. This sudden supply of energy to overcome the static friction of electric motor and fan, camera flashes. So while starting fan or camera or motor, it gives a small jerk, tuck, like the sound will come. Why na? It requires more energy to start them. After that, normal current only required. So starting only it requires more current or more electrical energy. So that electrical energy suddenly required, that can be supplied by a device that call it as capacitor. So capacitor is the device which stores electrical energy and supply it at once. Or we can say that capacitor is a conductor which stores electrical charge, electrical charge. So means capacitor is a device which stores electrical energy in the form of electric charge. So means it will store electrical energy or electrical charge, both are same. It supplies suddenly more amount of current or energy. Due to that fan motor will be start and overcome the static friction and start the fan. So that device we call it as capacitor. We know generally condenser, it's not like this is the condenser. So this is the condenser which stores electrical energy in the form of electric charge. So this supplies, it is the condenser. So small, this is the condenser. It stores energy and gives sudden supply of energy. Because of that motor and fan it will start and gives starting jerk and then it will start. Yes na? So that device we call it as capacitor. So it has capacitance. Capacitance. So capacitance means it is the property of conductor. It is the property of conductor which has ability to store electrical energy or charge electrical charge or electrical energy. See here, capacitor is the property of conductor which has ability or capability to store or to hold electrical charge or electrical energy, to hold electrical energy, and it gives suddenly to the fan or motor, so then it will start. So that property we call it as capacitance, device we call it as capacitor. Capacitor is the device, capacitance is the property. Stores, it will hold, ability to hold electrical charge or electrical energy. So this is the basic information. See, capacitor, it is the device which store electrical energy and supply it at once. Means supply it once is suddenly supplies energy. Yes na? Or capacitor is a conductor which stores electrical charge in the form of electrical energy. See, capacitance, it is the property of a conductor which has ability to hold or capacity to hold electrical charge or electrical energy, is called as capacitance. See here, capacitance, how to write now mathematically. Capacitance is the ratio of charge and potential. See, capacitance C equal to charge per potential, charge per potential. See, charge na q, potential na v. So means C equal to q by v. C equal to q by v. C means capacitance, q means charge, v means potential. See here, charge na unit coulomb and potential na unit volt, coulomb per volt. So this we call it as farads. So means what is the unit of capacitance in SI system na? Farad. It is scalar quantity. Capacitance is the scalar quantity. Its dimensional formula is m power minus 1 L power minus 2 T power 4 A power 2. It is the dimensional formula of capacitance. See how to write now here. Dimensional formula na C equal to what? Q by V. Q means Q by V. Q na charge. Charge na A into T. Potential na work by charge. means here m l power 2 t power minus 2 into a into t. Yes na, we can write here a square t square by m l 2 t power minus 2. It will changes to numerator na, m power minus 1 l power minus 2 t power 4 a power 2. It is the dimensional formula for capacitance. See, capacitance na charge per potential, charge na q, potential na v. So c equal to q by v. Q na unit coulomb, potential na volt, coulomb per volt we call it as farad. See how to write na here f capital letter. See, it is scalar quantity, we know it has no direction, only magnitude. See, its dimensional formula is m power minus 1 l power minus 2 t power 4 a power 2. How it will get na, c equal to q by v. So means charge na current into time, potential na work by charge. So means it will changes to numerator na a into t. So ml to t power minus 2. See, a square t square by m l power 2 t power minus 2. It will changes to numerator m power minus 1 l power minus 2 t power 4 a power 2. It is the dimensional formula of capacitance. See here its capacitance. For example, we can take one conductor. It is the conductor. See, it has a charge plus q charge plus q charge. Here see, charge q, capacitance c, potential v. It has charge is q, capacitance c, potential v. See, for example, we can so small dq charge, so which is taken from infinity and placed and stored in this sphere, in this conductor. In this conductor, we have to do some work. Why? Because already positive charge is there, it has some potential and electric field which opposes the dq charge. It is positive, it also positive repulses. So we have to do some work and stores in this one. See, already potential is more is there. So means capacitor means charge will be stored. Means what is capacitance? Capacitance is the property of a conductor which has ability to store energy or electrical charge. See here, it will store here. When it will store now, capacitance increases. Already potential more is there, opposing force more is there, capacitance will be decreases. For example, here see, charge will be less is there, so less charge. So definitely it will means we can keep here dq charge and hold here. So on one more dq charge, hold here. So means charge holding is increases, potential here decreases. Why? Because here less charges is there. So means it for electric field and potential is less. So capacitance increases. So it will be up to certain quantity only. Why? Because it is defined quantity. So that's why potential more is there, capacitance less. Means elect whole ability to hold charge is decreases, automatically capacitance decreases. Here charge is less is there, potential less, so means ability to hold charge is more, so means that case capacitance increases. Means here it will be happen up to defined quantity. So it's a particular conductor has particular capacitance is there, up to that it will happen. See, for example, so resistance equal to V by I. See, resistance is not depends upon potential and current. Like that, capacitance is not depends on Q and V. It will be for up to defined quantity only it will changes. So means here, for example, see here, we can take it is the conductor. It has a positive charge. So means more positive charge is made here, electric field is maximum is there. See, means strong electric field is there here near this air molecules is there. In this air molecule is neutral, it has positive and negative charges. Because of this electric field, what happen now here, charges will be polarized. Charges will be polarized means it is the positive charge, it attracts negative charges. That's why negative charges will be moved this side and positive charges will be this side. Why? Because positive charges are repelled, so that's why it will be polarized to another side. Means negative charges is one side, positive charges another side. See, this negative charges discharges means combine with this neutralize. See here, that case if this potential means this charge will be decreases. So charge decreases, capacitance decreases. So means here potential is more, capacitance decreases. See here, this discharge of charged particle we call it as corona discharge. See here, again listen, this is the conductor, it has more positive charge is there. Due to this it has a strong electric field, strong electric field, and the potential is strong. Yes na, this case near to this conductor if air molecules is there. So what now here, these air molecules neutral, so positive charges will be this side and negative charges will be this side, means charges are polarized. Means now here, so air molecule is polarization of air particle, polarization of air molecules, means here negative charges one side, positive charges one side. So this negative charges, so discharges means this will be combined with plus and neutralize, means that for example this charge is 2 coulombs, because of this neutralization or discharging, what happened now, 1.8 coulombs is there. Yes now, so means this process, discharging of charge, process of discharging of charge due to strong electric field and polarization takes place, due to that it will be discharges, that process we call it as here corona discharge, corona discharge. Yes na, see in this one what we can say now, so capacitance is not depends on charge and voltage, it will be depends on, see capacitance is the property of a conductor, so that's why it is depends on dimensions of the dimensions of conductor and property of the medium. What we can say now here, capacitance is depends on dimensions of the conductor and property of the medium, not depends on, C is not depend on Q and V, like resistance is not depend on V and I. So means not depend on voltage and current, resistance. When it is defined quantity for particular conductor, like that capacitance also defined quantity for particular conductor, it is not depends upon charge and voltage. It only depends on dimensions of the conductor or material. So property of the medium only, property of the medium only. Yes na, see. Now we discuss spherical capacitor or spherical capacitor. See, we can take here spherical capacitor. So means conductor. So it conductor na total charges will be resides on surface. See, this is the charges resides on surface. Positive charge is there here. See, its radius is capital R. What is the capacitance na? C, charge is Q, potential is V. For this spherical capacitor, spherical capacitor, for this we can derive the formula for capacitance. See here, it has capacitance C, charge Q and potential is V. What is the capacitance formula? Capacitance equal to Q by V or delta V we can write. So what is the here na charge Q, potential means due to spherical conductor, what is the potential on its surface na? See, potential on surface equal to K Q by capital R. It is the potential. See, we can write here Q by K Q by R. We can write Q cancel. What we get now here, R by K. Means K means here proportionality constant. That value is 1 by 4 pi epsilon naught. Instead of this R by K value, we can write 1 by 4 pi epsilon naught. What we get now here, 4 pi epsilon naught R. Means capacitance of the spherical capacitor is 4 pi epsilon naught R. See here, spherical capacitor means spherical conductor. So conductor na definitely charges will be resides on surface of the charge. Here see, capacitance is C, charge is Q, potential is V. This case capacitance equal to what? Q by V, means charge per potential. So charge na Q, what is the potential na here? See, radius is R, on surface what is the potential on surface now due to spherical conductor? So kq by r, kq by r. See, we can write instead of v, we can write kq by r. Q cancel, what we get? R by k. R means radius, k means here proportionality constant. K value is 1 by 4 pi epsilon naught. Instead of r by k, we can write 1 by 4 pi epsilon naught. What we get now here? 4 pi epsilon naught r. So means capacitance of the spherical conductor is 4 pi epsilon naught. See, C equal to 4 pi epsilon naught. Here r means radius, means capacitance of the spherical conductor depends on dimensions of the conductor, dimensions of spherical conductor, or and property of the medium, so means capacitance will be depends on its radius and property of the medium. See, for example, we can do the problem here. If radius equal to 1 meter, then find what is the find capacitance of the spherical capacitor. Capacitance of spherical capacitor, spherical capacitor. See here, what is the formula for spherical capacitor? Capacitance of the spherical capacitor, C equal to 4 pi epsilon naught R. C equal to 4 pi epsilon naught. R equal to what here? 1 meter. Here we can write 1 meter. So what we get now here? C equal to 4 pi epsilon naught. Actually, k equal to 1 by 4 pi epsilon naught. Its value is 9 into 10 power 9 Newton meter square Coulomb power 2. So we can substitute here. So C equal to what we can write now? It will be here, it will changes to here, means 4 pi epsilon naught value is 1 by 9 into 10 power 9 we can get. So we can multiply with 10 denominator and numerator. What we get now here? 10 by 9 into 10 power 10. So that will divide now here 1.1 into 10 power minus 10 farads we get. That we can write here 1.1 into 10 power minus 4 microfarads. So this is the capacitance of the spherical capacitor if radius equal to 1 meter. What is the capacitance now? 1.1 into 10 power minus 4 microfarads. See here, again listen once. R equal to 1 meter, then find capacitance of the spherical capacitor. So capacitance is formula is 4 pi epsilon naught R equal to what here? 1 meter. So we can write 4 pi epsilon naught into 1 meter. See, C equal to 4 pi epsilon naught. C equal to 1 by 9 into 10 power 9. Why? Because 4 pi epsilon naught value is 1 by 9 into 10 power 9. We can multiply numerator and denominator with 10. So 10 by 9 into 10 power 10 we get. That case we can divide na 10 by 9, 1.1. It will be changes to numerator 10 power minus 10. 1.1 into 10 power minus 4 microfarads. So it will convert into microfarads na. 1.1 into 10 power minus 4 microfarads it will come. See here, next concept. See, if capacitance is 1 farad. Next problem, if capacitance is if capacitance is 1 farad, then find radius of the spherical capacitor. Spherical capacitor. See here, what now here we discuss. Before what we discuss, if radius is 1 meter, what is the capacitance of the spherical capacitor? What is the capacitance here? 1.1 into 10 power microfarads. So but now here they give capacitance. What is the capacitance now? 1 farad. For that, what is the radius of the spherical capacitor? So that we discuss. See here, for example, what is the formula for capacitance of the spherical capacitor? C equal to 4 pi epsilon naught R. We want here radius. So radius means R equal to C by 4 pi epsilon naught. C equal to what they give? 1 farad. So we can write here 1 farad by 4 pi epsilon naught. See here, actually K equal to 1 by 4 pi epsilon naught. This value is 9 into 10 power 9 Newton meter square per coulomb square. See, we can write here R equal to 1 by 4 pi epsilon naught value is what now we get here 9 into 10 power 9 meters we get. See, this is the radius of the spherical capacitor of capacitance 1 farad. So capacitance is 1 farad. Now that case, what is the radius of the spherical capacitor? Now 9 into 10 power 9 meters means even surface of radius of earth is 6.4 into 10 power 6 meters only. Then this more sphere is there, that sphere provides 1 farad of capacitance, means that one is very difficult. So what now here C equal to 1 farad. What is the radius of the spherical capacitor? Now R equal to 9 into 10 power 9 meters. That much length of large length of radius of sphere na, so then only it will provides 1 farad. Means from that what we can say na, spherical capacitor provides less resistance, sorry, less capacitance, See, now we discuss how to store the energy in spherical capacitor. Yes na. See, for example we can take energy stored, means electric potential energy of spherical capacitor. So means energy stored in spherical capacitor, spherical capacitor. See, this is the concept. Now see, here we can take one spherical conductor. It has charge plus q, capital Q. See, this in this one starting no charge is there. For example, we can store charge. So means dq charge is taken from infinity and hold here in the surface of the spherical conductor. For that we have to do some work. So that amount of work done in bringing dq charge or dq element from infinity to placed in spherical conductor, so that amount of work done will be stored in the form of electrostatic potential energy, that we call it as energy stored in spherical capacitor. For example, see, this dq is taken from infinity and placed in or stored in spherical capacitor. Starting here no charge is there, so means no positive charges is there. First we can take dq charge and place here. For that what we can do here, work done by external agent, work done by external agent external agent in bringing each each dq element from infinity to sphere this sphere. See, this is stored in the form of electrostatic potential energy. For example, see, t equal to 0, so charge equal to 0, so potential equal to 0 when it is defined for spherical capacitor. C is there, so this one, so no charge means at t equal to 0 time no charge is there, charge is 0, potential 0. T equal to t time. So after that what we can do, we have to do some work done by external agent to bring each dq element from infinity to this sphere. This dq stored in this sphere, that storing dq can be stored in the that for storing dq we have to do some work done. That work done will be stored in the form of electrostatic potential energy, that we call it as energy stored in the spherical capacitor. See, t equal to 0 time, q charge is 0, potential is 0. See, t equal to t time, so charge will be q, small q, and potential is q by c, q by c. See here, what now, what next now, is dq charge, dq charges, each dq will be stored in this one. So after time t, what now here, charge will be small q and potential is q by c. Time t equal to t time, t equal to t time, charge is stored q and potential is q by c, potential is q by c means, so work done by external agent, work done by external agent in bringing, in bringing each dq element from infinity to sphere. This sphere has charge q, potential v, capacitance t. C. That case we can write what is the work done by external agent in bringing dq charge from infinity to this sphere. So that we can say that potential difference. See what here, it is the initial potential, it is the final potential. So means initial, final, final minus initial. So means this has potential is what, v, v minus what is here, final, v infinity, that equal to, we can write work done by external agent in bringing dq element from infinity to sphere. So we can write here infinity to sphere. So we can write here, yes, we can write by what na charge, dq charge. Here work done is dw work done. See, dw work done utilize and bring dq charge from infinity to store here, we can place here in sphere. So that case how much of work is done on charge, that will be stored in the form of potential, or that is potential energy. So that we can write here v minus v infinity, that equal to dw work by external work, work done by external agent, so infinity to sphere, so by dq charge. From that here v infinity is 0, what we can write here, v equal to dw by dq. From that we can write dw equal to v dq. So means here v dq. Now here see, total work done, total work done, work done by external agent, external agent, that equal to what we can write now, integral dw. So means here for dq some work done, next dq some work done, next dq, mean this all dq's added, we get the total work done, and total charge will be stored in this one. So that total work done will be stored in the form of energy, that energy we call it as electrostatic potential energy stored in the sphere. So that we can write here dw equal to integral what now, v dq. See here, where to where, 0 to q, starting t equal to 0, q 0, charge 0, potential 0, t equal to t time, charge is small q, potential is q by c, t equal to infinity time, q equal to capital Q, v equal to capital Q by c. So means finally what here, capacitance is defined here. So that capacitance we store, find out, that is dw equal to integral 0 to q v dq. Here we can write w equal to, means work done equal to by external agent, that is integral 0 to q now v dq, v means q by c, so means integral 0 to q dq. So means here work done equal to, so 1 by c is common, q is there, q square by 2, integral of q means q square by 2, we can write 0 to q. So what we get now, work done by external agent, that equal to q square by 2c, upper limit we can write, later lower limit q square by 2c minus 0 we can get, what is the now, q square by 2c. Work done means this work done will be stored in the form of energy, that we can write here delta u, delta u equal to q square by 2c, delta u equal to q square by 2c. Like this we can store the energy in spherical capacitor. Starting now here no charge is there, we have to do some work and bring the dq charge from infinity to store the sphere. So one by one, see like this. So dq we can take and store, dq we can take and store. So what na t equal to 0 time, no charge, no potential. After some time t, what na, due to this external work done, so how much charge is stored? Small q, potential q by c. After infinite time, what na, q equal to capital Q charge on a potential is q by c. So we get the, what is the charge, total charge. See here, after infinite time, total charge will be stored in the spherical capacitor by doing some external work. That external work will be stored in the form of energy, that is electrostatic potential energy stored in spherical capacitor. So that is delta u equal to q square by 2c, u final minus u initial. U initial is 0. Why? Because at infinity. So we get what now? U equal to q square by 2c. What is the formula for potential energy stored in spherical capacitor na? U equal to q square by 2c. See, I write here, what is the energy stored in spherical capacitor na? U equal to q square by 2c. So in u equal to q square by c means we know formula. What is the formula for capacitance of the spherical capacitor? 4 pi epsilon naught r. Instead of c we can write 4 pi epsilon naught r. We get u equal to q square by 8 pi epsilon naught r. It is the one more formula for electrostatic potential energy of the spherical capacitor. This is one, this is one. So for example, in terms of c and v na, we can write c and v. For that, q equal to what? We can write cv. So u equal to what? Q square by 2c. Instead of q we can write cv, means u equal to q square, means c square v square by 2c. 1c cancel, what we get now? Here u equal to 1 by 2 c v square. So means here c means capacitance, v means potential. In terms of c and v na, 1 by 2 c v square. In terms of, in terms of q and v na, we can write c equal to q by v we can take. See here, for example, see, u equal to what? Q square by 2c. Instead of c we can write q by v. C equal to q square by 2 into q by v. So q cancel, what we get now? U equal to qv by 2, that equal to 1 by 2 q into v. So means u equal to qv 1 by 2 into qv. This is the one more formula. See, what is the formulas for energy stored in spherical capacitor na? It is one formula, u equal to q square by 2c. Or we can write instant in terms of radius na, u equal to q square by 8 pi epsilon naught. Or in terms of c and v na, what is the formula na? U equal to half cv square. In terms of q and v na, potential energy of spherical capacitor equal to 1 by 2 q into v. So these are the formulas for potential energy stored in spherical capacitor. Q equal to q square by 2c, u equal to q square by 8 pi epsilon naught r, or u equal to 1 by 2 cv square, or u equal to 1 by 2 qv. Yes na? See, what is the disadvantages of this spherical capacitor? Yes na? See here. So disadvantages is, see, spherical capacitor, capacitance is what na? Capacitance of the spherical capacitor is 4 pi epsilon naught r. Potential energy is here, see, q square by 2c1, u equal to q square by 8 pi epsilon naught r1 energy, u equal to 1 by 2 c v square 1, u equal to 1 by 2 qv, one formula. See, these are the electrostatic potential energy of spherical capacitor. It is the capacitance. What now? What is the main disadvantage of spherical capacitor now? See first one. It stores it stores less capacitance. It stores less capacitance. Capacitance. What is that capacitance now? 1.1 into 10 power minus 4 microfarads. It means it stores very less capacitance. Yes na. So this is the first disadvantage. Second one is, see, in spherical capacitor energy is energy is not bounded, not bounded. So not bounded means, for example, here spherical capacitor energy will be stored in this one. It will be here from radius center to near. Now capacitance is more going, and it will be distributed to infinity. Up to infinity it will be distributed, not bounded. So because of that it will be rejected. So actually why the spherical capacitor is rejected now? It stores less capacitance. What is the capacitance of the spherical capacitor? 1.1 into 10 power minus 4 microfarads. For example, 1 farad of capacitance will be stored. Now we require 9 into 10 power 9 of radius of that much length of radius of the sphere we want. That one we can't provide. So that's why it is less capacitance it stores. How much now? Here 1 meter of spherical capacitor, how much energy stored now? Here how much capacitance now? 1.1 into 10 power minus 4 microfarads only. See, energy in the same way, energy is not bounded, not in between the bounded. It will be distributed from center to infinity. It will be distributed, its energy will be decreases. So these two regions, because of these two defects, the spherical capacitor is rejected. Instead of this spherical capacitor, they introduce parallel capacitor. So that one we discuss in next class. So this is the introduction of the capacitor and capacitance. What is spherical capacitor? How to store the energy in the spherical capacitor? So work done. How much of work is done in bringing charge or each dq element from infinity to required spherical capacitor? That work done will be stored in the form of electrostatic potential energy. That electrostatic potential energy formula is q square by 2c, u equal to q square by 8 epsilon naught r we can write 1 by 2 cv square, or we can write 1 by 2 qv. So this is the energy formulas. And capacitance, spherical capacitor, this one. So we discuss, this is the information about capacitor and capacitance, introduction only. Yes na. See the my videos and subscribe the channel and share to your friends and relatives. Thank you.